General Motors, the biggest automaker in the US, is diving headfirst into the electric vehicle game. They're not just talking about it, they're betting their future on it. GM CEO Mary Barra has a bold vision for an all-electric future, one with zero crashes, zero emissions, and zero congestion. She's confident that GM will dominate the US EV market by the middle of the decade, claiming they'll take the #1 spot. The Ultium battery. The star of GM's EV push is the Ultium battery. This isn't just any battery, it's a game plan wrapped in cutting-edge technology. The Ultium system starts with a single cell of flexible building block that can be adapted for all kinds of vehicles. Imagine a system so versatile it can power a massive Hummer, a sleek Cadillac Lyriq, or pretty much anything else GM dreams up, and they can do it fast. GM is putting its money where its mouth is, planning to pour $35 billion into electric and autonomous vehicles by 2025. The goal: to produce over 1 million EVs annually and launch more than 30 electric models worldwide, most of them based on the Ultium platform. By 2035, GM plans to make all of its light-duty vehicles electric, and they're not stopping at personal cars, BrightDrop, and commercial EVs. GM is expanding into the commercial EV sector through its BrightDrop brand. They've already started delivering BrightDrop vans to FedEx and secured a contract with Walmart. It's clear they're serious about carving out a major slice of the EV market. The Ultium platform. What makes GM's Ultium platform stand out is the collaboration with LG Energy Solution, a battery manufacturing powerhouse. Together, they're building 3 massive battery plants in Ohio, Tennessee, and Michigan. GM believes this partnership and its advanced battery design will make its EVs among the best on the market. But Ultium isn't just about better batteries, it's a complete rethinking of how EVs are built. From motors to software, everything works in harmony. The Ultium battery is a large-format lithium-ion design, the beating heart of GM's electric future. Tim Grew, GM's electrification chief, explains that it's about combining cutting-edge components into one seamless system. The modular design allows the battery to be scaled up or down, perfect for anything from heavy-duty trucks to sleek sedans. To simplify, GM engineers describe battery operation in familiar terms. Imagine anodes and cathodes as parking garages where lithium ions park depending on whether the battery is charging or discharging. Battery chemistry innovation. Traditional EV batteries often rely heavily on cobalt, a metal that's expensive and difficult to source. Tesla, for instance, uses a mix of nickel, cobalt, and aluminum in many of its models. But GM's Ultium chemistry is breaking new ground. It uses less cobalt and includes other elements to reduce both costs and dependence on rare materials. They're even working toward cobalt-free designs, which could be a game changer for the entire industry. This shift isn't just about cutting costs, it's about sustainability. Mining cobalt and similar materials can be environmentally damaging and politically complex. By reducing reliance on them, GM's Ultium batteries aim to make EVs cheaper, greener, and more sustainable for the long term. The new EV ecosystem. Beyond the tech itself, GM's vision involves building a complete EV ecosystem. The Ultium platform integrates a new software ecosystem designed to manage power delivery, extend range, optimize charging, and allow over-the-air updates just like Tesla. This means GM vehicles can continuously improve with new updates, better performance algorithms, and smarter energy management, all without visiting a dealership. In short, Ultium isn't just smart hardware, it's intelligent software. The battery management system's smarter, cheaper, and more sustainable. GM's battery management system is another technological leap. While most automakers monitor the battery pack as one unit, GM takes it a step further, tracking individual modules. If one module underperforms, it can be replaced independently without swapping out the entire pack. This approach reduces waste, lowers repair costs, and makes upgrades easier. It also means future GM vehicles could potentially mix older packs with new modules, extending lifespan and reducing environmental impact. Flexible battery design. Built for every market. GM has even reimagined how the physical cells are shaped and packed. Most consumer electronics use pouch-style batteries, which are thin and flexible but not strong enough for cars. GM took that concept and reinforced it, adding insulation, improving thermal management, and ensuring the cells can withstand the demands of a 10-plus year vehicle lifespan. The cells are packed tightly with almost no wasted space, maximizing energy density. This flexible design allows GM to adjust the shape and size of battery packs for different markets, for example. Shorter, wider cells for compact cars in Asia, and longer cells for larger US vehicles. It's a global system designed to adapt locally, and that's a massive competitive edge. The bigger picture, GM's bid for the future. What's happening at General Motors right now isn't just an upgrade, it's a transformation. A century ago, GM defined the gasoline era. Today, it's positioning itself to define the electric era. By combining cutting-edge science, large-scale manufacturing, and a bold vision for sustainability, GM's Ultium platform could mark the start of a new chapter, not only for the company, but for the entire American auto industry. They're not merely building cars, they're building the blueprint for a cleaner, smarter, and more connected future.
One of GM's key innovations is how they pack the cells. Rather than leaving gaps between them, GM arranges the cells tightly side by side, reducing wasted space and maximizing energy capacity. This design is incredibly flexible, allowing GM to adjust the shape and configuration of the cells depending on the vehicle's needs. For example, their cars in China use a prismatic can design, which is shorter and wider compared to the longer cells typically used in the US. Speaking of China, the country is the world's largest electric vehicle market, and GM has made some serious moves there. In 2021, GM sold 2.9 million vehicles in China, with their new energy vehicles, including both plug-in hybrids and fully electric cars, seeing major growth. Their Buick Velite EV lineup, for instance, doubled its sales year over year, reflecting the increasing demand for EVs in the region. In fact, GM has been so successful in China that it now sells more EVs than Tesla in the country, which is no small feat given Tesla's prominence in the global EV market. The Ultium platform's flexibility goes beyond just battery chemistry and design. It extends to how the batteries are assembled within vehicles. GM's modular approach means that the battery modules can be arranged both vertically and horizontally, depending on the vehicle's requirements. For example, a full-size truck might have up to 24 battery modules stacked together, while a smaller vehicle like a sports car might only need a single layer of modules. This adaptability allows GM to optimize battery size and configuration for each specific model, ensuring efficiency without overcomplicating the manufacturing process. Take the Cadillac Lyriq as an example. Its battery pack is designed with 12 modules, carefully chosen to meet the performance needs of the vehicle. Meanwhile, for a smaller car like the Chevy Equinox EV, fewer modules are required, resulting in a shorter and more compact pack.